After showing the powerful linear void planning in the last video, we want to take a look at the collaboration with linear. We're using the same model as last time and assume that we do a coordination of the void proposals with a structural engineer. In the first step, we now open the export dialog. Here you can select, for example, that only the proposals from the current view should be exported, and we also have the option of exporting an IFC model with all provision for voids with the BCF file, which enables a void planning with users of other CAD platforms in an open BIM workflow. As the coordination process often runs through multiple communication loops, you can also specify whether already coordinated proposals should be exported again to reduce the complexity. At the bottom, you can choose the desired directory as well as a name for the BCF file. I will call this one voids MEP. Now we start the export and get all proposals in the Issue and Task tab as well. These now initially have the status proposal, and I can now add more information to the individual voids. For example, I can navigate to the involved components and add a screenshot. Also, a comment to this proposal can be saved here. Using the right mouse button on the BCF, I can then go directly to the directory and send the file to the structural engineer or store it on a project server. The structural engineer, in turn, loads this BCF file and can then evaluate the proposal and decide whether they are acceptable or not. For this purpose, the respective status is set to accepted or rejected, and a comment is added if necessary. If the structural engineer also worked with Revit, he can perform this coordination very conveniently using the free Linear Void Manager, which you can also download and pass on to the architecture or structural engineer directly from the export dialog. I will show you how the Linear Void Manager works within the next video. But even without the Linear Void Manager, the structural engineer can now edit the BCF and assign an appropriate status, which he can do natively in Revit as well as in another authoring platform. When the structural engineer finished his editing, he sends us back the BCF file. And I can now link this as a new topic in the Issue and Task tab and see the status set by the structural engineer in the issue report. Using the coordinate function, I can now transfer these information into my model. To do so, I select to compare the BCF from the structural engineer with the provision of voids in the model, and now all proposals are updated in the model and colored according to their status. Red means rejected and green means accepted. Unprocessed voids remain yellow. At the rejected void, we then also find a comment given by the structural engineer that no void should be integrated larger than 700 millimeters. Now I can develop alternatives for the rejected voids and send the new proposal to the structural engineer for another review. We go through this process until a solution is found for all collisions. By coordinating directly in the model, all parties involved have identical information and can thus perfectly work together in the model to get a common result. This is workflow instead of workaround.